We'll now begin section 4.1 and discuss polynomial equations and graphs. We'll begin with the discussion of the zeros of a polynomial. The number k, and k may be a complex number, is a zero of the polynomial function p of x if p of k is equal to 0. This is also expressed by saying that k is a root of the polynomial or a solution of the equation p of x is equal to 0. A polynomial equation in one variable, say the variable x, is an equation that can be written in the form a sub n times x to the nth plus a sub n minus 1 times x to the n minus 1 and so forth is equal to 0, where n is a non-negative integer. The a values are constants. Assuming your leading coefficient is not equal to 0, we say that such an equation is of degree n. Let's begin with an example and try to illustrate what is being discussed in these definitions. Our first example asks us to verify that the given values of x solve the corresponding polynomial equations. So we're being asked to figure out in part A if x is equal to 4 is a solution to 6x squared minus x cubed is equal to 12 plus 5x. If we look back at our first screen, we know that the number k is a zero of the polynomial function if p of k is equal to 0. And another way of saying this is to say that k is a root or that k is a solution of the equation. So let's consider this part A of this first example. If x is equal to 4 is a solution to the equation 6x squared minus x cubed is equal to 12 plus 5x, what that means is that if I plug 4 into the expression everywhere there's an x, I will get a true statement. So let's check and see. So I'm going to say 6 times 4 squared minus 4 to the third is equal to 12 plus 5 times 4. Following our order of operations, we'll deal with the exponents first. So 4 squared is 16, so we have 6 times 16. 4 to the third is 64. And then we have equal to 12 plus 5 times 4. We'll do our multiplications next. So we'll do 6 times 16. 6 times 16 is 96. Minus 64 is equal to 12 plus 20. 96 minus 64 is 32. And 12 plus 20 is 32. So since this is a true statement, we can conclude that 4 is a solution to the polynomial equation. Let's go ahead and look at part B of this same problem. Part B, we're given the polynomial equation x squared is equal to 2x minus 5. And we're trying to check and see whether 1 plus 2i is a solution to the equation. Remember that we said that our solutions may be complex numbers, which is what we're seeing in this example. So let's try this and see. I'm going to take 1 plus 2i and I'm going to plug it in for the x's. So I'll have 1 plus 2i and then squared is equal to 2 times 1 plus 2i minus 5. Again, we'll do our exponents first. You may want to come off to the side somewhere and let's determine what 1 plus 2i times 1 plus 2i is actually equal to. Remember, that's going to need to be done by FOIL method. So first times first is 1. Outside is positive 2i. Inside is positive 2i. And last would be 4i squared. And remember that I squared is equivalent to negative 1. And so what I can do there is I can come in and in place of this I squared, I can put a negative 1 and then further simplify. So let's see what we have here. We have, this will become a negative 4. And we have a positive 1, which makes a negative 3. And we have a 2i and a 2i, which makes a 4i. Coming to the right-hand side, we'll distribute our 2, which is going to give me 2 plus 4i minus 5. So our left-hand side will remain through negative 3 plus 4i, and our right-hand side will become 2 and negative 5 makes negative 3 plus 4i. So again, we have a true statement, which means that 1 plus 2i is a solution to the equation. All right, and finally, let's go to our part C. Our polynomial equation is x over 1 minus I is equal to 3x squared. And our possible solution is x is equal to 0. So let's go ahead and plug 0 in. So everywhere there's an x, I'm going to put 0. So on the left, I get 0 over 1 minus I. And we know that if we have a fraction with a 0 in the top, that it doesn't really matter what's in the bottom, that fraction is going to become 0. And over here, we're going to have 3 times 0 squared, which is also going to be 0. And so again, we're getting a true statement, which means that x is equal to 0 is a solution.